When we talk about disruptive innovation, the classic example used is Netflix. Netflix did not reach the mainstream until after disrupting its business model from mailing DVDs to online streaming. Netflix disrupted the television industry and forced cable companies to change the way they do business. We bring this example up to illustrate how a company can achieve greatness by innovating and focusing on problems overlooked by competitors in the targeted market. But you might be wondering, what in the world does Netflix have to do with the title of this video? I'm Miss Paws, and that's what we're going to dive into today. Innovations in one field often heavily impact progress in another. For example, 3D printing can be used to print rockets that make space exploration cheaper and efficient. 3D printing has also disrupted the aerospace industry as we are not only able to print parts that are stronger and lighter than parts created using traditional manufacturing, but we are able to print the whole rocket. So you might have heard the term disruptive innovation being thrown around a lot. What does it actually mean? The theory of disruptive innovation was introduced in 1995. Lots of improvements have been made since to the theory, so there are a lot of misconceptions about what makes something disruptive. According to the Harvard Business Review, disruptive describes a process whereby a smaller company with fewer resources is able to successfully challenge established incumbent businesses. Just as new tech allowed Netflix to switch from mail to online streaming and disrupt the market, 3D printing has enabled aerospace companies to create complex components previously impossible with traditional techniques. 3D printing has thus fostered innovation while reducing cost and turnaround times in a complex, highly regulated environment. 3D printing is a vast topic in itself, but for the purposes of this video, let us quickly understand the basics. 3D printing, or additive manufacturing, is basically a process of making 3D solid objects from a digital file. So, how does it work, and why would we need it? The process starts with the 3D model. You can opt to design one yourself using 3D modeling software or download it from a 3D library. Slicing software takes scans of each layer of a model and will tell the printer how to move in order to recreate that layer. Once the model is sliced, it's sent off to the 3D printer for the actual printing process. The nozzle of the printer moves back and forth while dispersing layer by layer the material it uses to print. Additive manufacturing has permeated almost every industry. Other than being able to print Iron Man's helmet, 3D printing can do a lot of things. We can't possibly go over all of its uses, but let's look at how 3D printing is used to solve several problems. On Earth, in healthcare, 3D printing was used to make masks and ventilators during the COVID-19 pandemic, and is also used to mass manufacture more durable and low-cost prosthetics. 3D printing houses, which can combat homelessness, is faster, low cost, and generates less waste than traditional methods. Outside of Earth, 3D printing in the International Space Station. NASA and spacecraft engineering company Made in Space are trying to understand how we can 3D print in space. Made in Space uses the benefits of microgravity or weightlessness to develop innovative new products and concepts that can only be realized in space. Made in Space pioneered the use of 3D printing technology on the International Space Station, allowing NASA and other International Space Station stakeholders to avoid wasting valuable space on rockets, with equipment that can easily be 3D printed in space. Now they can store feedstock or raw materials such as plastics and even metals on the space station and print tools and components they need, like wrenches, hammers, and fans. 3D printing a home for astronauts living on Mars. Though no human, or cat, has ever been on Mars, that hasn't stopped architectural firm AI Space Factory to start designing houses for the surface of Mars. Using 3D printing and AI, they enabled the autonomous construction of a Mars habitat known as Marsha. The habitat is created from a recyclable biopolymer composite, which outperformed concrete in NASA's strength, durability, and crush testing. So, to better illustrate how all of these terms are connected, let's look at a startup that's solving problems most people don't even know exist. Relativity Space is a rapidly growing rocket startup. Most people know about SpaceX and Blue Origin, but Relativity Space remains relatively less known to those of us who aren't space enthusiasts. Repeatedly launching rockets costs a lot of money that startups can't afford, hence limiting our pursuit to be a multiplanetary species. Relativity Space is solving this problem by building the first autonomous rocket factory using 3D printing. Not only are manufacturing costs being cut down, but the number of parts that the rocket needs are also being dramatically reduced. The company can thus optimize and reiterate designs at low cost. Now, the question can be asked, what's so disruptive about this company with a not so creative name? Well, not only is Relativity Space building rockets 10 times faster with 100 times fewer parts than traditional rockets, Relativity Space's long term vision is to 3D print humanity's infrastructure on Mars. And if that doesn't give you literal chills, I don't know what will. As the launch costs continue to decrease and the implementation of new innovative ideas becomes more accessible to startups, I wonder what other tech and ways of the aerospace industry will begin to be disrupted. As the vision of other companies like SpaceX and Relativity Space comes true, we are one step closer to becoming a multiplanetary species.